video, we will demonstrate one of the quickest ways to get up and running with OpenStudio. Whether you are creating your first model or looking to perform a quick analysis on a building, we will use the OpenStudio application to apply a powerful OpenStudio measure, the Create DOE Prototype Building measure. This measure will quickly generate a fully functional energy model. After running the measure, we will use the OpenStudio application to inspect and modify some of the input parameters of the model, which will allow us to visually see the changes that we will make to the model. We will then execute the energy model, which will be an annual simulation of the building, and we will review the results. Reviewing these results will ensure that our model ran as expected. Now let's begin with an empty OpenStudio model. Normally, weather files are required for every OpenStudio simulation. These files can be downloaded or purchased from several different sources. The Create Prototype Building measure will import a default weather file into our model for us, so we will skip this step. The Create DOE Prototype Building measure can be retrieved from the Building Component library. You can use the OpenStudio's Apply Measure Now feature to apply this measure to our model. We must save our model before applying this measure. We can then find this measure underneath the Whole Building Space Types category. We simply need now to select the measure arguments: a building type, medium office, a building template, 90.1 2010, and a building climate zone, ASHRAE 90.1 2006, climate zone 5A. This will allow us to generate a building that contains the default values for a code-compliant ASHRAE 90.1 2010 medium office building located in climate zone 5A. As the measure executes, it describes the model objects being created and their attributes. To accept this model, select Accept Changes. Under the Site tab, we can now see that the measure has added a weather file for Chicago, Illinois. The measure has also added Design Day files for Chicago, Illinois as well. The Design Day weather files have been added, which provide representative days used to size the heating and cooling systems in the model. We can further inspect this OpenStudio model by selecting from other tabs in the ribbon on the left. For example, when we select the Geometry tab, we can see the 3-story medium office building that the measure generated. We can use the controls at the top right to more closely inspect the form and fabric of the model, such as changing the rendering modes and switching on or off visibility of model elements. For example, only viewing walls or only viewing windows. We can also click on objects to determine their properties. We can see that we just saved hours of work by using this measure that has created everything from walls, windows, roofs, floors, insulation, and other construction materials, including detailed HVAC systems. The properties of all of our model elements are visible in other elements in the OpenStudio ribbon and can be inspected and edited from within the OpenStudio application. For example, lighting internal gains associated with a space type can be viewed and changed. Let's maneuver to the Space Type tab, the Load sub-button, and we will see that the lighting definition is named Office Whole Building Medium Office Lights Definition. We can go to the Loads tab and examine that lighting definition. We see that we have a default value of 0.9 watts per square foot, which we can easily change to a value of our desire, for example, 0.5 watts per square foot. So if you know your building is a little different from the 90.1-2010 prototype that we created, we can quickly and easily make changes to our model. For example, we can change people density, plug load equipment density, and other inputs that were created as part of this prototype model. By maneuvering to the HVAC Systems tab, we can also access OpenStudio's HVAC editor. This user interface makes reviewing and editing HVAC system properties very easy. Let's inspect the supply fan pressure currently specified for the air handler serving the 5 thermal zones on the first story of this building. And we will reset it to a more energy efficient value of 2.5 inches of water supply fan pressure. We can tell that this air handling unit is serving the bottom floor, again, the 5 zones on the bottom floor of this building. We simply click on the supply fan, maneuver to the right under the Edit tab, maneuver to the input parameter called fan pressure rise, which has a default value of 5.5 inches of water, which again we can replace with a more energy efficient value of 2.5 inches of water. Additional properties of the fans and the coils in the air handling unit in general can be edited by clicking and editing. Now, finally, properties of time-varying OpenStudio objects can also be changed using the OpenStudio application. Let's take a look at a cooling thermostat schedule. First, we'll maneuver to the Thermal Zone tab, and we'll see that our thermal zones are controlled by a cooling thermostat schedule named Office Medium Cooling Setpoint. We'll now maneuver to the Schedules subtab, where we will find that cooling thermostat schedule. In the OpenStudio application, lists are presented in alphabetical order. So we will find our thermostat schedule here. And we click on the default run period, and we will see our building is currently set to cool to 75.2 degrees Fahrenheit. If we wanted to change those values, we could simply double click to create a break and drag the horizontal section or drag the vertical bars to the times and values that we desire. We can also hover over a bar and simply type in a value, for example, 68 degrees Fahrenheit, and the value will adjust accordingly. For each hour of the year, OpenStudio requires thermostat schedules, heating and cooling thermostat schedules, to have a non-zero gap or a non-zero deadband between them. If we do not have a non-zero deadband, the model will not simulate correctly. So do be careful. Careful inspection of the companion heating thermostat is needed to make sure that we do not have a non-zero deadband between the heating and cooling set point for a particular hour. So we'll set this back here. And again, if we want to remove those gaps, we just simply double click. Once we've refined our model, our prototype model, it's very simple to go to the Run Simulation tab, again, the Run Simulation tab, and simply execute our model. Activating the green Run button will execute an hourly simulation of our model as we have described it. The feedback pane gives us feedback on simulation progress. When the simulation is complete, we can maneuver to the Results Summary tab to review the results. The standard method for reviewing OpenStudio results is the OS OpenStudio Results Report. We can maneuver through using the tree on the left. The data we can again look at, which can be either tabular or presented as a chart, and tabular data can be scraped, copied, and pasted into other applications such as spreadsheets for further post-processing. We can also review the Energy Plus results. The Energy Plus results are presented in tabular data form. If we maneuver to the table of contents of the Energy Plus results, we get a little bit of an easier way to maneuver through them. And I would point out that the Energy Plus results are often presented in units of SI, such as gigajoules and megajoules per square meter and whatnot. While the Energy Plus results are in SI units, the OpenStudio results are presented in IP units. Well, congratulations, you have now completed your first building energy model. Once you are more comfortable with this process, try generating other prototype models of different vintages, different climate zones, different templates, different sectors and types. And try adding more detail to your model. Try replacing other parameters in your model, such as chiller efficiencies, people densities, occupancy schedules, and whatnot. And try applying additional measures and creating your own building geometry. In our next video, we will cover using OpenStudio's floorspace.js geometry editor, and we will again show us how to create custom geometry to expand the use of the prototype buildings.